All right, hello there, NAMS class. This is section 5.6. It's the third video of section 5.6. We're going to talk about some scientific notation today. Easy stuff, not hard at all. Free points, who wants some? Hopefully you're paying attention and we'll pick this up because it's easy. All right, so starting off, we are going to talk about some basic terms, and then we are going to roll through this guy. So, starting off with scientific notation. What is scientific notation? Well, each number written in scientific notation is written as a number between 1 and 10 that is multiplied by a power of 10. Let me make that easier for you with some examples. If we had 5.2 times 10 to the third power, that is in scientific notation. It is a number in between 1 and 10, 5.2 multiplied by 10 to a power. We can also do scientific notation to negative powers. For example, 2.4 times 10 to the negative fifth power. That's an example of scientific notation as well. Now you may be asking yourself, why do we do scientific notation? What is the purpose? Scientific notation allows us to write, very large, or very small, numbers easily. All right, so let's talk about how we do this. First thing we're going to do, when we convert from scientific notation to decimal notation, we will determine the exponent. For example, in 2.5 times 10 to the third power, 3 is the exponent. Very important. Now, if this exponent is negative, for example, if it was 2.5 times 10 to the negative third power, we will move the decimal point that many places to the left and fill it with zeros. If it were to the positive power, let's say it is 2.5 times 10, to the positive 3 power. In that case, we would have a positive power and we would move the decimal 3 spaces to the right, filling in zeros where necessary. Now let's look at a couple of examples of this. 2.5 times 10 to the 6th power. I'm going to write out the number 2.5. I'm going to look at the exponent. It is positive, therefore I need to move to the right. So I'm going to move 6 spaces, 1, 2, 3, 4, 5, 6 to the right, and fill in zeros everywhere there's a little space at. That makes that actual number 2,500,000. Let's take one to a negative power. If we had 4.77, it was multiplied times 10 to the negative 4 power. It's a negative power, so the exponent goes to the left. 1, 2, 3, 4 times, and I will fill in all the areas that I need to with zeros. This is 0.000477. All right, moving on to our next set of examples. Same idea. 6.9 times 10 to the 8th power. We start out with the number 6.9. We will then take that decimal point. Having a little trouble here. Let's get that right. And move it 8 spots. It is to the positive 8 power, so it's going to the right. 1, 2, 3, 4, 5, 6, 7, and 8. Fill in all areas with zeros. 1, 2, 3, 4, 6, 7. And end up with a final number. After we put our commas in, comma there, we have 690 million. 2.3 times 10 to the negative 5 power. Let's start out with the number 2.3, and we realize that the power is negative, so we will move it backwards to the left 5 spaces. 1, 2, 3, 4, 5. Filling in zeros everywhere. There's a space. That becomes 0.00023. Basic stuff with scientific notation, not hard at all. Now we have converted from scientific notation to decimal notation. Now we need to go do the reverse. Go from decimal notation to scientific notation. So here's the idea. We're going to take our number and move the decimal point to the original number, finding a number that is in between 1 and 10. We then count the number of spaces we moved. If we moved left, the exponent's positive. If we moved right, the exponent's negative. Let's put that into practice. Here's the idea. We look at this number, 450,000. Now, first of all, it's bigger than 1. It's a huge number. It has to be to a positive power. I'll just give you a hint there. The way to do it, though, our decimal point right now is right here. We will move it to where we can find a number in between 1 and 10. So, well, that's not there. I can't. You get here, you're like 450, still not in between 1 and 10. 45, still not in between 1 and 10. But if I put it right there, 4.5 is a number in between 1 and 10. Now we count the number of spaces we moved. We moved 1, 2, 3, 4, 5, 6, 7, 8 spaces. And since we moved those 8 spaces to the left, it is to a positive 8 power. I would check it at the end too and look at it. To the positive 8 power needs to be a big number. It definitely is. Same idea here. We're going to move our decimal point until we find a number in between 1 and 10. So I'm going and I'm looking. No, 0.123 is not. Whoop, right there. 1.23 is a number in between 1 and 10. Let's count the spaces. 1, 2, 3, 4, 5 spaces. And we moved 5 spaces to the right. That's why it's to a negative power. All right, last one. Going through, I'm going to move the decimal point until I find a number in between 1 and 10. I'm going to take a little while on this one, but we'll get there. Bam! There it is, 9.6. Is there a number in between 1 and 10? And we're multiplying that times 10 to what power? 1, 2, 3, 4, 5, 6, 7, 8, 9. I moved it 9 spaces, and I moved it 9 spaces to the right, so it will be to the negative 9 power, plus it's a really small number. Last one. Decimal point is right here to start. Moving it until I find a number. 10.5 is close, but not quite. That's bigger than 10. I need in between 1 and 10. And 1.05 is in between 1 and 10. Times 10, let's find the power. We moved it 1, 2, 3, 4 spaces to the right, which makes it to the positive 4. 1.05 times 10 to the 4th power.